Hello. In my last video, I briefly explained what an IDE is and what it does. I also said that I will be making one myself. So, in this video, I will discuss my current plan of making this IDE. Making an IDE is not a simple task. It takes a lot of time and patience. There are a lot of things that can go wrong. This means there will be a lot of challenges ahead, and my current plan may change in future depending on the situation. Leaving that aside, there are four major and most common IDE components that I want to discuss in this video: the build system, code analysis, project management, and user interface. So let's start with the build system. Any program written in a compiled programming language needs to be built in order to run. Building a program means taking the source code in a file and passing it through a compiler and linker to obtain an executable that can run on a computer. For small projects, this can be done manually, but as the project scales, the manual approach is no longer efficient. This job needs to be automated, and that's exactly what a build system does. It takes all the source files and calls the compiler and linker automatically. It also keeps track of changes in the files so that only the files that have changed are compiled. This saves time and resources by not having to compile entire codebase for every tiny change in a single file. Many pre-existing build systems like GNU Make, Ninja, MS Build, and others do just that. They take input, a build script, or a project file that has information about other source files and compile the application. Some high-level build script generators like CMake and Premake can generate build scripts and project files for these build systems. An IDE can use one of these pre-existing build systems or have its own. Visual Studio uses its own build system based on MS Build. CLion and KDevelop use CMake to generate build script for many build systems. CodeBlocks has its own build system, but it can also use GNU Make to build projects. Qt Creator uses Qt's own QMake build system, but it can also use CMake. From these examples, it is clear that there is not a single way to build programs. For my IDE, I have decided to use a hybrid approach. It will have its own build system along with support for CMake, something similar to Qt Creator. I may add support for other build systems like GNU Make or Premake in the future. Now, let's discuss about code analysis. An IDE must provide proper code completion feature to assist the developers. To do this, it needs to understand the code structure and project files. And in order to do that, it needs to parse all the source files. This is a difficult job, especially for complex languages like C and C++. IDEs like Visual Studio and CLion have their own proprietary code parsers. They are robust and professional-grade parsers with deep integration in the respective IDEs. But sadly, I cannot use them in my own IDE. I can surely make my own code parser from scratch, parse all the code into my own abstract syntax tree, and deeply integrate this parser in my own IDE, just like Visual Studio and CLion, but with the power of open source. That's a great plan, but as great as it sounds, it is also very complex. Making a robust C++ code parser is worthy of its own separate project, and I already have a massive project of making an IDE, so making my own code parser is out of question. Luckily, the LLVM team, especially the people behind CLang, have built an entire C++ compiler, and the compiler automatically comes with a code parser. And it doesn't end there. Developers of CLang are kind enough to open source the entire CLang codebase for anyone to integrate the CLang parser into their own project. From here on, CLang team provides two options. The first one is an LSP server, CLangD. It is an external executable that provides a language server, much like a web server. Just like web browsers can communicate to web servers and receive web pages, LSP clients can communicate to CLangD server to receive code analysis and code completion. Code editors like VS Code, Sublime Text, NeoVim, Emacs, and IDEs like CodeBlocks and CodeLite use CLangD through plugins and extensions for C++ code completion. Another option provided by CLang team is a C library called libclang. It can be integrated directly into the source code of any IDE or code editor. This approach is used by kdevelop for code parsing. For my IDE, I will be using the second approach, similar to that of kdevelop. There are a few reasons for this. First of all, libclang can be deeply integrated into the source code of the IDE. This provides greater control over code parsing. And secondly, in my opinion, relying on an external LSP server for code parsing is not ideal for an IDE. The next thing that I want to discuss is project management. An IDE should be able to create and manage software projects. A software project in the context of an IDE is the collection of all relevant source files, build scripts, and additional resources. IDEs typically handle this by generating a separate file that contains information about the project structure. This can be further abstracted through the concept of a workspace. A workspace file contains information about one or more projects related to the same software. Visual Studio generates its own project files and groups them under a workspace. Rather than calling it a workspace, Visual Studio calls it a solution. JetBrains IDEs have their own project structure, and so does every other IDE. For my IDE, I have decided to take on Visual Studio's approach towards project management. I will be using a simple XML file to store the project structure. This file will be passed into the build system that will build the project, similar to how Visual Studio stores its project information in its project files, which can later be passed into MS Build. Workspace will not be implemented for now. That's all for the project management section. Now it's time to discuss about the most interesting part of the IDE, the user interface. An IDE must allow its users to write code in a code editor and provide a good user interface that integrates all aforementioned components. So for the user interface of my IDE, I will be using SDL3 for window management and DRIM GUI for UI components. Now, if you have ever used these libraries and know about UI creation, you will notice that this isn't the traditional approach taken by most IDEs. Most IDEs use a retained mode UI, but DRIM GUI is an immediate mode UI library. Visual Studio and JetBrains IDEs use custom-built proprietary UI libraries. Kdevelop uses Qt, whereas CodeBlocks and CodeLite use WX widgets. All of these are retained mode UI libraries. I cannot use the proprietary UI libraries of Microsoft and JetBrains. Qt is too heavy and complex, whereas WX widgets lacks customization and a modern look. So, I have decided to go with an immediate mode UI library that is lightweight as well as highly customizable. Lastly, I want to discuss the tools that I will be using in this project. I do need to write code and build them, so I will be needing a code editor and a build system. Since I'm making my own IDE, I won't be using any pre-existing IDE. Once this IDE is somewhat functional, I will use it to write its own code. For now, I will write its code in base Sublime Text and will use CMake to generate build scripts. So that's my current plan. Thanks for watching and see you in the next video.